Yeah, in the last part of this week, I promise it's really the last part, we're talking about similarity models for time series. And not necessarily already about how to measure the similarity between time series, not necessarily, so not about distance measures. We will talk about distance measures later on next week. But first of all, there are different ways to compare sequences on a higher level, independent of the distance function or distance measure. And we'll talk about that now. So let's see what's that about. So we start with some examples here for similarity queries, meaning what kind of similarity on a higher level we want to find between sequences of time series in a database. So for example, we may have time series that measure the growth of companies, and we may want to find companies with similar growth patterns, yeah, or we have selling patterns or selling time series of products, time series measuring how often a given product is sold over time, and we want to find products that have similar selling patterns, or we have stock data and we want to discover stocks with similar movement in stock prices, or we have a music score database and we want to find scores that are similar to one that has a copyright protected. Yeah, so all these things are different applications, of course, and in all parts we could think about comparing the entire time series that we have with each other, but also in all of those cases we could think about, well, for example, take this musical score thing. If we just find a subsequence of the time series that is similar for one specific music score that is similar to a copyrighted one, then we may already think about some kind of violation of the copyright. Yeah, so we not necessarily want to compare the entire time series, but we may also just be satisfied with comparing sequences, subsets of the time series. Yeah? So this is what I meant with similarity models on a higher level. What kind of comparisons do we want to do on a higher level? Regardless of any distance function, we have two types of similarity queries, similarity notions, so to say. The first one is where we compare time series over the entire length of their time series. Yeah? So that is called a whole matching. The time series are usually assumed to all have the same length, and we want to match entire time series when we compare or compute the similarity among these time series. We want to match the entire time series on each other. And the second part, where we are satisfied with the subsets, a sequence, is called subsequence matching. So here, time series may also have different length, and when we want to compute the similarity, we want to find the subsequence that has the best match between the two time series that we compare. Yeah? So those are two different notions, absolutely independent of the distance function or the distance measure. In the first case, we really want to compare the entire time series. In the second scenario, we just want to find maybe the best subsequence match between two time series, but we don't care if this is just a subsequence. We don't need to compare the entire time series. Yeah? And of course, we can measure these similarities in these different scenarios again in many different ways, and we'll see at least a couple of examples for that. First of all, to illustrate that, so here is the illustration of the whole matching scenario. So let's have a query object, or here it's even a query template. So this is a iconic template, so to say. Yeah, so not a real query object, and maybe we want to match the entire database. So this is the database consisting in that case toy database of 10 time series. So if we want to do a whole matching, we really compare the entire time series with this query template. Yeah, so we try to match each and every database as a whole against the query template. Yeah, so in that case, for example, it says that 06, this one here, is the best match for the query template, and the similarity again is measured over the entire time domain. And that is now different when we do the subsequence matching. So here is the illustration of that. So again, we have a query template. We have a lot of time series in our database. So maybe this is one time series in the database, and you see the query template is much smaller, much shorter than the time series in the databases. The time series objects in the database. Yeah? So here you see we try to find the position in O in this specific time series object where the query template matches best, and this is, so to say, the best matching part. So we compute the similarity between the entire thing here and the query template just based on this position here, which is the best match for the query. Yeah? So this is a subsequence matching scenario, and that sometimes makes sense. For example, if you consider this here as some music score which has a copyright, and this is a new score coming in, and you want to know did someone did a good or bad plagiate of some copyright thing. Yeah? Okay. Yeah, and there is a variant where the length of the best matching subsequence is fixed to some n. So in that case, for example, the length here of the query template may be fixed to some specific number of time slots. And if that is the case, then you can use a sliding window with n to go over the entire database objects and extract from one time series objects all the from one time series object all the subsequences of this length n, and store that in the database. Yeah, so that would be of course blow up your database in terms of number of objects, but instead of having, I don't know, objects of length 200 in the database, maybe your window is 20, then you can decompose all those big 200 length time series into time series of length 20, yeah, with a sliding window, and you get a lot of smaller time series in that case. Yeah, so and of course a lot of redundancy also. So it's not a one-to-one matching, but of course you blow up your database with this kind of scenario. But that can help you, and then because then you are again in the whole matching scenario in that case, if you do that with this sliding window here, obviously. Yeah. So those are the two different general scenarios, and based on that, of course, you can apply then different similarity measures or distance measures. And here is a non-exhaustive list, maybe one of the more popular measures. Minkowski distances, we'll talk about that, uniform time warping distance, dynamic time warping, longest common subsequence is also there for time series. We'll talk about those four a little bit more in detail. We won't talk about edit distance with on real sequences and on with real penalty, shape-based distances, just that you can also apply edit distance on time series, of course, since it's a special case of sequences, but you can also use some shape-based distances. Yeah, so we will mainly focus on the first four here, and as promised, we will talk about that next week. So hope you are healthy and everything is fine, and stay tuned, be patient, and talk to you next week. See you.